Hey, for this video, we'll be going through electrical system worksheet exercise 1. So let's start. Question 1, which of the following is the electrical symbol for a variable resistor? Okay. Um, for variable resistors, we also call it rheostat. Okay. And answer is D. Okay. So those of you who are actually going through this together with me, can you also write down what are the names of the other symbols? So this is ammeter. Okay, and bearing in mind ammeter, there's always plus and minus, and ammeter must be connected in series. Ammeter measures current. Okay, now he has and we have another meter called the voltmeter. Voltmeter is always connected in parallel, and it also has a plus and minus. Okay, and plus to plus, minus to minus, and it measures voltage. Okay, don't be surprised that in your WA or exam you are asked to draw from pictures of circuit using circuit symbol. Okay, you will be asked to draw. Now, question 2 on the circuit below, name the electrical appliances shown. So this is a switch, this is a resistor, then we have lamp or bulb, and this is my rheostat, also known as a variable resistor. What is electric current? Is the rate of flow of charge through a circuit. Conventional current always flows from positive to negative. Okay, but electrons flows from negative to positive. Now, where is the positive terminal of the battery? Where is the positive terminal? Remember subway? Okay, so subway long is positive, and current comes out from the positive terminal. Okay, so as we are going through this, please annotate. Don't just look at the answers. Okay. Now, in what circuit charges are not allowed to flow and they use AND, that means the following word must start with A, E, I, O, U, right? So in an open circuit. What is the opposite of open circuit? Opposite is closed circuit. Only in a closed circuit will current be able to flow. Now, potential difference between 2 points, potential difference I told you all is also somewhat called voltage. Between 2 points in an electric circuit is the amount of energy needed to move a unit charge from one point in the circuit to another point. You might want to take note that number 7 and number 3, they are both definitions. So sometimes you will get your to state the definition, meaning what they mean. Okay, so please take note of that. Can I move on? Current is measured using an ammeter. In a circuit, it is connected in series. This is very important. Potential difference of voltage is measured using a voltmeter. It is connected in parallel. Okay. Now, which diagram shows an ammeter and a voltmeter connected properly or correctly? Now, remember, ammeter must be connected in series. So, in this case, the ammeter is connected in series. This is in parallel. This is in series. This is in parallel. So, I'm marking out the correct or the wrong position of the ammeter in the 4 options. For voltmeter, it must be connected in parallel, so this is correct. This is in series for the voltmeter, so it's wrong. Similarly for this is correct. So the answer is A. Now, we can also do some marking here. If A is the correct answer, this part of the battery is positive, this is negative. So what do I mean by positive to positive, negative to negative? It means that this part of the voltmeter is positive because it needs to be connected to the positive. We have done the experiment whereby you saw the needle deflect. You weren't able to get any reading. So that is because you have swapped the plus and minus of the voltmeter, right? So this part will be the negative, negative. For the ammeter, if A is the correct answer, this part is the negative, this part is the positive. Okay? Sometimes you'll be asked to label the positive and negative. Now, electrical what have high resistance to? Electrical conductors. Electrical insulators. You must also be able to give some example, which is basically your metal. Then you have iron and copper being some very good conductors. Insulators, you have either wood or rubber. Okay? So you must be able to give some examples. Question 13. How much resistance, this is my letter R, allows a voltage of 6 volts, this is my letter V, produce a current of 0.006 ampere, this is my I. So you need to know the formula of V equals to IR. Right? You need to memorize this formula. And if you were able to identify who are the numbers, what do they represent? You can substitute V as 6, I as 0.006, then my R is the unknown, right? So after you do that, you'll get R to be 1000 ohm. Okay? And ohm is actually the unit for resistance. Okay? So you need to know your alphabet, know your letters. Okay, then question 14, it has a resistance of 3 ohm. I will annotate it as R here. Given that the potential difference across the lamp is 12 volt, I annotate it as V. Current, I'm supposed to find, I annotate it as I. So V equals to IR. After you annotate, after you have identified, it becomes easy to substitute into the question, okay, into the formula. My V is 12, my I is unknown, my R is 3. Do your math properly and you will get I to be 4 ampere. Okay, so this is it for exercise 1. Okay, we will now continue with electrical system worksheet 2. Okay, question 1, in a series circuit, there's only what through which electric current can flow? One path. Okay, for a moment I was a bit stunned because I don't really know what to fill in, but I look at series, there's only one path. Now, adding a resistor in series to another increases the overall resistance and decreases the current. What do I mean by that? What is the formula for resistance in series? The formula is R effective is R1. If let's say there is only one resistance, then it's R1. But what if we add one more in series to it? Then the formula becomes R1 plus R2. So the resistance will actually increase, right? Therefore, the current will decrease. Now, in a Watt circuit, electrical components are connected to the cell in 2 or more loops. That means there are 2 or more paths, several paths, so this is a parallel. Okay, adding a resistance in parallel, it actually decreases the overall resistance. Now, the formula for parallel, it is 1 over REFF equals to 1 over R1 plus 1 over R2. Now, don't forget to flip this when you do your fractions, and it is very important to have a calculators, okay, so you can help. Overall resistance decreases, but the current actually increases. So whenever your resistance decreases, your current will increase. It always goes the other way. Okay, so now can we calculate the overall resistance of the following setup? First thing that you need to know that this is a series. The second one also series. This is parallel because there are two paths, and this is parallel because there are three paths. Okay, so this will be simple. 2 plus 1.5, you get 3.5 ohm. This is 2 plus 6 plus 3, we get 11 ohms. For this, we have to apply this formula. I'm doing this question with the formula like that. Now, if you have your calculator, you can straight away get 1 over REFF equals to 2 over 4. You flip it, your REFF, which is your RC, equals to 2.0 ohm, right? You flip both sides. Okay? How about for RD? Again, I apply the formula for resistors in parallel. 1 over R1 plus 1 over R2 plus 1 over R3, and I will get something like 1 over 1 plus 1 over 2 plus 1 over 3. Make them into common denominator. Okay, for me, because I don't have a calculator now, I have to do mental sum. And 6 plus 3 plus 2, right? Over common denominator of 6. Okay, so it's very lengthy. You see that if you do not have calculator, you are disadvantaging yourself. So it is equals to 11 over 6. Is this the final answer? No. You actually have to flip it. So it becomes 6 over 11. Okay? Right? Yeah. So you cannot leave it in fractions. If you have your calculator, press 6 over 11, you'll get a certain value, write down the units of ohm. Okay? So this is for question 5, calculating the effective resistance. That means all of these resistors in the circuit can be replaced by one single resistor. So how does it help us in question 6? We have two identical resistors placed side by side, 3 ohm and 3 ohm. So this is my R, my R. Okay, what is the overall resistance? Easy, 3 plus 3 because they are connected in series. So equals to 6 ohm. Calculate the amount of current drawn from the battery. Now, if I do not ask you all for A, if I ask for the amount of current drawn or the amount of current flowing through 3 ohm, let me draw this here. If I never ask you all for the effective resistance, a lot of students will fall into this trap. I ask for the current that flows through the 3 ohm. What will students do? I use pink color to show the wrong answer. A lot of you will just take 6 divided by 3 because the current is situated very near to the 3 ohm. So you will get 6 divided by 3 equals to 2 ampere, right? But this is not the answer because we need to take into account the total resistance, right? So if I were to redraw this circuit, after I have found the effective resistance, I have 6 ohm, I have 6 volts. So if you look at this, are these two circuits equivalent? They are. But now if I use my V equals to IR, I have 6 equals to I6. So my I is actually 1 ampere. And that is the correct answer. Okay? So I hope you understand this. Don't just take it at face value. You need to find the effective resistance. Now, indicate with an arrow direction of current. Current always comes out from positive, subway, positive here. So this is my current. Okay? Now, question 7, it is parallel because there are two paths, right? So we have X and Y, 3 ohm and 6 ohm. Calculate effective resistance in parallel. Apply the formula because now you know they are parallel. 1 over 3 plus 1 over 6, 1 over REFF equals to 3 over 6, right? So don't forget to flip. So my REFF is equals to 6 over 3. So equals to 2.0 ohm. Okay. Now calculate the amount of current drawn from the battery. So how do we find that? There are actually two ways, because just now I taught you all about the sum, same, sum. In parallel, the voltage is the same. In parallel, voltage is the same. So the voltage here is 6 volt. The voltage here is also 6 volts. So if I know the voltage across X, which is a 3 ohm, I will know that the current is 2 ampere. I will know that the current here is 1 ampere. I hope you all understand this. If any question, please ask. So what is the current that comes out from here? It is 3 ampere, because in parallel, the current is the sum. You add them up. Is there another way to do this? There is, because I asked you to find the effective resistance, right? So let me redraw this with the effective resistance of 2 ohm, 6 volts. What is the current that flows out? The current that flows out is V equals IR, 6 equals to I, 2, I equals to 6 over 2 equals to 3 ampere. It actually tallies with what I did. Yeah, it actually tallies with what I have done over here. Okay, so the final answer is 3 ampere. Okay, let's continue with question 8. 3 resistors, 2 ohm, 4 ohm, and 6 ohm, they are connected in parallel. It is supplied by a 12 volt battery. Let's sketch the circuit diagram. So I have my battery, this is 12 volts. I have one path of 2 ohm, one path of 4 ohm, and one path of 6 ohm. Okay, very quickly I sketch it out. Is this the circuit that you have drawn? You must make sure that they are in parallel. So calculate the overall resistance. So I apply the formula of parallel resistor of 1 over R1 plus 1 over R2 plus 1 over R3. So 1 over REFF equals to 1 over 2 plus 1 over 4 plus 1 over 6. Okay, so again, I don't have calculator. I have to do 12, 6 plus 3 plus 2. So I get 11 over 12. But that's not the end of this REFF, because now it's 1 over REFF. Therefore, my REFF is actually equals to 12 over 11. So I think it's 1.09 ohm, right? 3SF. You all have done it. You all can help me check. Is this your answer? So it's 1.09 ohm. Okay. Now calculate the amount of current drawn from the battery. So I took quite a while to find the REFF. I'm going to use it in my calculation, because I can actually replace my circuit of 3 resistors in parallel into 1 resistor, which is my REFF. So let me find the current. V equals to IR, 12 equals to I, R is 1.09, and therefore my current will be, you all can press your calculator, okay? 12 divided by 1.09. Oh, I actually have the answer here. It's 11 ampere, alright? So this is for worksheet 2.